Okay, welcome to our second lesson. In this lesson, we're going to create a third-person camera controller. So as you can see, the camera is controlled by the right stick. We move it right or left. It moves on the x-axis. Now this is kind of weird. If we move it up or down, it actually moves in and out and does not rotate on the y-axis like most modern games do. And that's actually something we're going to change. So we're not going to recreate this camera one-to-one. This type of camera is kind of old school. Probably quite common when this game came out, but for modern games, this is kind of a bit clunky. So we're going to take some liberties in our recreation. We're going to create a more modern camera to go with the game. Also, as we can see, we can bring the camera behind this tree, and we can actually cover our player. We can't see him. There's a little bit of logic there. If we get it the right place, it stays still, but a little bit of logic for obstacle detection, where it automatically pushes out to the side. Instead, what we're going to do is pull our camera forward, which is a bit more modern way of doing things. Okay, let's jump to Unity. So if you go on YouTube and you look up a tutorial for a third-person character controller, you'll most likely get suggested an implementation that uses a package called Cinemachine. And Cinemachine is quite good, it's quite powerful. But personally, I like to use a custom camera just because you have a lot more flexibility, a lot more control over what you can do with it. So yeah, that's what we're going to do. So of course, we go to our scripts. Let's create a new folder called camera. Within this folder, of course, we're going to create a new C# script. Call this third person camera. Double click and open that up. And of course, as always, first thing we do, delete all this. Now, first variable we're going to need is the transform of the object itself. So, transform, and of course we call it in transform. We're also going to need the transform of the target that we're going to follow, which will be the player. So we want this to be available in the inspector. Serialized field, transform, we'll call this follow target. We're also going to need a transform for our pivot, and I'll explain what that is later when we set up the camera, but just add this for now. We're going to need a follow speed, which would be a float. We will also need a rotate speed, which is a float as well. And now we get into some private variables. So these will become clear, the use for them as we go on, but we're going to need what's called a look angle. And we also are going to need a float pivot angle. Perfect. Now we're also going to need to set a min and max pivot. So that's basically how much above the character's head you can look and how much below that you can look at. So we'll go serialized field. We'll go float min pivot angle, and let's just default this to minus 35 F for now. So it's be minus 35 degrees. And then we need a max pivot angle. And let's make that 35 degrees. So you have 70 degrees of motion in total for the y-axis. Okay, now let's create some methods. So instead of using start, of course, we're going to use our custom init function. So public void camera init. And of course, we're going to call this in our game manager once we're finished. And transform will equal transform, simple. We're also going to do this little thing, cursor dot lock state equals cursor lock mode dot locked. And what this does is your cursor on your screen, instead of it going everywhere, it's going to be locked dead center. And then we're also going to hide our cursor. So we don't want to see our mouse in the middle of the screen. We want that gone. So we'll go cursor dot visible equals false. Now we'll do our update. Public void camera update. We're going to need to take in our input container. Call it input container. And we're also going to need our delta, which is a float. Okay, so let's create some methods now. So of course we have a follow target, so we're going to need a follow target method. So void follow target. And all we need for this is the delta. And this is quite simple. So let's do a vector 3, call this target position. And of course this is going to equal vector 3 dot lerp, which means to linearly interpolate between 2 points. So the 2 points are our M transform, so our current position. And we want to move it towards our follow target dot position. We want to move it at our follow speed multiplied by our delta, just to make this frame rate independent. And then simply to set our M transform dot position equals target position. And that's it. Let's go in here and call this follow target delta. Perfect. So let's just test this actually while we're here. So let's go to our game manager and our update now. We also want to get our third person controller. So serialized field, third person camera. So it's a camera. We'll go camera dot camera init. So I think this is a keyword. Yeah, let's just rename this instead to third person camera. And of course, we want to call the update as well. And feed in our input handler dot input container and our delta. Cool. Now if we go back to our game, let's create a new empty. Let's call this third person camera. Let's make sure the position is the same as the player, which is 0, 0, 0. And then we're going to create an empty underneath this. This will be our pivot. Then underneath this, we're going to create another empty. We're going to call this camera holder. Now, our current camera in the scene, we can move that under the camera holder, and we can reset the position of this. So now, we're modifying our camera. We'll modify the height or the Y position through the pivot. So let's move this up, maybe to about there, maybe 1.25. And then we'll modify the Z value through our camera holder. So move this back, maybe -4. Let's bring this up a bit higher too. I think that's good. That's too high. Let's go 1.75. Okay. Now let's attach our script. Third person camera. Our follow target is going to be our player. Our pivot is going to be our pivot. Our follow speed, let's just put it at 5 for now, and we can change it. Rotate speed, let's just put it at 10. And now, what happens if we press play? Oh, we have to go first to our game manager, of course. Drag and drop our third person camera. Now, let's press play. Let's see what happens. So as you can see, the camera follows the player. It doesn't rotate yet, we still need to do that, but it seems to be working well. If we decrease the follow speed, there'll be a bit of a delay before it catches up. Let's put this at 1. So we can see now that delay. I think 5 is quite good though, so leave this at 5. Let's go back to our code now for our third person camera. We're going to do void handle rotation. This is going to take in our input container and our delta. So first thing we need to do is get the look angle. So look angle is going to plus equal our input container dot right stick, because that's what we're controlling it through. Multiply that by our rotate speed, and then we multiply all this by our delta, and this has to be dot x, of course. And then our pivot angle is going to be minus equals our input container dot right stick dot y this time, multiplied by our rotate speed, and then multiply that by delta. Now, to make sure that our pivot stays within our min and max, we want to say pivot angle equals math f dot clamp, not clamp 0, 1, but clamp. And then we want to set it to be between our min pivot angle and our max pivot angle. And then of course, actually we need to put the pivot angle as our first argument in this. Okay, so that's how it's supposed to look. So that means if the pivot angle is below, we have a set as, so by default it's minus 35. If it goes below that, it just won't, it'll lock it to minus 35. Same if we go above 35, this will lock it to 35. Then we want to apply this to our camera object. So we go vector 3, Euler. So a Euler is a type of angle. This is default of vector 3.0. And then our Euler dot y equals our look angle. And then our Euler dot x equals our pivot angle. And I actually think this is pronounced Euler, not Euler, but I've heard it both ways. I think Euler is the correct one. Let me know if it's not. And then we want to apply this rotation. So quaternion is going to be called target rotation equals quaternion dot Euler. And what this does is it translates an Euler angle to a quaternion. So we put in our Euler. And now that we have a quaternion, we can actually apply this to the game object. So M transform dot rotation equals target rotation. Now, just to make this a little bit cleaner, because obviously I've played with this before, I know how it works. Sometimes your lock angle will go above 360 and it'll become 361, 362, blah blah blah, and keep going up. Same for minus values. Nothing will break, but sometimes if you're debugging and you see an angle that's 480, it's kind of hard to understand what that actually is. So what we'll do is, if our lock angle is greater than or equal to 360, or our lock angle is less than or equal to minus 360 degrees, then we're simply just going to set the lock angle to 0. So then, once we get to these line of codes, then our lock angle will be in the range of 360 again, which is easier for us to understand. Okay, now let's, of course, call this handle rotation, input container, delta, save. Let's go back to our game. We already have some values here. Let's see if this works. Press play. As you can see, this works now. I move my mouse the whole way down, and this is as low as we can go. So this is minus 35. And then if I bring it up, this is as high as I can go above the character. So that would be 35 degrees. On the x-axis, we can spin around as much as we want. And because in our character controller script, we control the rotation based on the camera direction, if we start moving the camera, the player will rotate as well, which is great. No extra coding needed. So this is basically it. It's quite simple, quite powerful. A few more things we can do to make it better, but I think already this is quite a nice camera. So one thing we can do that's quite a nice thing is we can create a camera reset. So, sometimes in games you can reset your camera by clicking in the right stick or whatever. So we can just recreate that here. So let's call this void camera reset. And let's just put a debug log, debug.log camera reset. And then, of course, our lock angle is going to equal. So we wanted to reset behind the player, which is our follow target. So we go follow target dot transform dot local rotation dot Euler angles dot y. And then we need to reset our pivot angle simply to 0. Now we can call this up here. So I'm going to do the right stick click in, as I mentioned. So if input container dot right analog input dot pressed, then simply preset camera. Okay. Let's grab my controller. Let's test this. So go back to our game, press play. Let's move the camera about. Maybe we'll change that camera rotation. It's quite slow at the moment. And let's move it way down. Now if I click this in, resets back to behind the player. Let's just change this rotation speed to let's see what 50 feels like on the controller. Yep, it's a bit slow. Let's say 100. Yeah, it feels quite good. Again, if we click in, resets. Cool. Now, one thing that we want to add is, what if the camera collides with something? So this is a plane, and it's only one-sided, so if we bring the camera below it, we can still see the player. But let's say we have an object that isn't like that. So let's just add a cube to the scene. Let's bring it up from the ground. Just pull it forward. Now if we press play, now let's actually just make sure our camera speed is at 100. Press play. Now if we move the camera like this, now we can't see the player. We can kind of walk through this cube. We don't want that. In most games, the way it works is when the camera collides with an object, it'll pull forward. So we could code that, and it's quite easy. We just need to make the z-axis, or the z value of the camera holder, pull in until it's not colliding. And that's quite easy bit of code to do. But this is where I'm actually going to use Cinemachine. So I said at the start we weren't going to use it, but we are, just not in the way that most people use it. So go Window, Package Manager. And there's a few reasons I like to use Cinemachine for this, because they have a lot of built-in stuff that we can make use of. So make sure it's in Unity Registry. Type in Cine. You can see it here. Let's install it. And now that that's installed, we can come to our hierarchy, create an object, Cinemachine. We're creating a virtual camera. Let's just leave it being called virtual camera. Let's reset the position. And now when we have this Cinemachine installed, it overrides the values of the main camera. So now if we go here, we can see it's got this new component attached called Cinemachine Brain. And if we try to move the main camera, it doesn't work, because the logic now is overridden by this virtual camera. So we can replace this, we can pull the main camera out, and the Cinemachine camera will now go under a camera holder. Let's just reset it, so it's back to where we want it to be. And the reason we're going to use this now is, if we go to add extensions, we can add a Cinemachine collider, which is what we want. To avoid obstacles, this requires a look at target, so we'll just set the player. We want to set the body to do nothing, and also the aim to do nothing. We just want this to be a virtual camera that does nothing else. We handle the movement logic ourselves through our script. And now we want the camera to pull forward if it collides with something. And for the layers, we want it to collide against everything except our player. So let's just quickly put our player on a layer, a zone. We'll call it player. Go back to our player. Change the layer. Yes, change children. Go back to our virtual camera. Everything but the player. So let's untick the player. And later when we do NPCs, we'll have them on their own layer, and we'll untick that as well. Now if we press play again, so we can see the camera pull forward when we bring it down to the ground. Same if we go to this cube, pull forward. It's very nice, that's what we want. So for some reason our rotation is changed on the X there, that's fine. Change that back to 0. So I think that actually pulls in a little bit too fast. Also, I think the camera goes too close to his feet and not above, not as much as the top. So let's change our virtual camera damping when included. Let's change that to 1. Okay, maybe that's too slow now for pulling in. Let's change this to 0.5. Still a bit too fast. Let's go 0.1. Still a bit. Maybe 0.25. Yeah, I think I like that better. And let's go to our camera. Let's change the min pivot angle. I think this is too much. So let's go -25. See how that feels. Yeah, I like that better. And then for max, I don't think this is enough, so let's go 45. Yeah, I think these are a lot better values. Still don't like how the camera jumps back. Let's go back to this. Put this back to 0. Maybe smooth time. That didn't change anything. Let's increase our damping. So that looks like it changes the speed of it coming back out. Okay, so I think we need to have a mixture. So let's set this to 1 and also our dampen to 1. So there we go. Now that feels a lot better. Let's go in front of this cube. Yeah, that feels a lot better. And same for our angles. I think there's a lot better angles. Let's just apply these values now because they are undone. Once we exit play mode, go back to our player. We want to, or our camera. Let's change this to -25. And this to 45. And that's it. Simple as that. We have a camera set up. So one reason I like to use this on the machine is because it has this collider already enabled. So it's quite easy for us to use it without having to code ourselves. But other than that, we usually want multiple cameras in our game for things like cutscenes or if we want to focus on an action. And with Cinemachine, it has a whole transition system already pre-built in. So if we create another virtual camera here, and let's just rotate it this way. Let's say this camera is being used for a cutscene. Now, if we make sure the priority is lower than your main one, so that's a 10. Let's say this is 9. Now, press play. Now, let's say we're running around with our player and we come up to this door and we press a button. Now we want a cutscene to play. We can just disable our main camera and then transitions to the static camera and we can play a little animation or whatever. And then if we re-enable our camera, it'll go back. And that saves us having to code our own camera system. It's quite handy. So that's it. We have a working third-person camera for a third-person controller. Obviously, this can be used for any type of game. In the next lesson, we're going to start looking at some NPC logic. and lots more fun stuff after that. Make sure you subscribe for my future lessons, and thank you very much for watching.